Hello students, welcome to the another video chapter diffraction of light at plane surface. Our today's lesson is total internal reflection in a prism. And what is total reflecting prism? So students, let's start. A prism having an angle 90 degree between its two refracting surfaces and the other two angles each equal to 45 degrees is called total reflecting prism. And the light incident normally on any of its faces suffers total reflection inside the prism. So next I will explain it through a diagram. So actually we shall consider total internal reflection in three different prisms. Okay. At first the 45 degree, 90 degree and 45 degree, which is called right angle isosceles prism or total reflecting prism. And a prism, second type is a prism of each angle is 60 degree, which is called equilateral prism. And third type is 30 degree, 90 degree, 60 degree, which is called right angle prism. There are three types of prism. We shall consider total internal reflection in these three different type of prism. So student, I just told that what is total reflecting prism? A prism having an angle of 90 degree between two refracting surfaces and the other two angles which is equal to the 45 degree is called total reflecting prism, because the light incident normally on any of its faces and suffer total internal reflection inside the prism. So here, due to this behavior, a total reflecting prism is used for following three purposes: to deviate a ray of light through 90 degree, to deviate a ray of light through 180 degree, and to erect the inverted image without producing deviation in its path. So students, just go to the first topic, to deviate a ray of light through 90 degree prism. And here in this topic I can show to all of you the right angle prism or total reflecting prism. So students, let's see. So here, to deviate a ray of light through 90 degree, in this figure you can see that this angle is 90 degree and these two are 45 degree. Okay. And here ABC is a total reflecting prism or right angle prism. A beam of light is incident normally at the surface AB. Okay. And it passed undeviated into the prism and strike at the surface AC at an angle of incidence equal to the 45 degree. Okay. And for glass air interface, the critical angle is about 45 degree. So therefore the beam of light suffers total internal reflection. Why? Because the angle of incidence is greater than critical angle. Okay, critical angle is 42 degree. So that's why the light suffer total internal reflection at the face AC, because the angle of incidence is greater than the critical angle. Now the reflected beam inside the prism then strike at the surface BC, where it is incident normally and therefore passes undeviated. So as a result, the incident beam gets deviated through 90 degree, emerging out through the prism. And from this figure, the path of two rays PQ and P dash Q dash through the prism and then out of it. You can see that. Okay. And also by the principle of reversibility, we know that the path of the light, if the light is incident normally on any surface of glass or prism here, so it will emerge out from the surface after suffering total internal reflection. Okay. So this is the deviation of a ray of light through 90 degree prism. You can say that what happened, the question may come like that, what happens when a light ray passes through a prism at 90 degree. And this action of prism actually used in a periscope, where a total reflecting prism is preferred over a plane mirror. Clear? So this is the first topic. Next, to deviate a ray of light through 180 degree prism. So here this angle is 90 degree and these two are 45 degree. So here the beam of light from the object PQ falls normally on the surface AC. Okay, which is the hypotenuse here of the prism. So it deviated inside the prism and strike the glass air interface AB, which is AB of the prism. Since the beam of light is traveling from glass to air at an angle incidence equal to the 45 degree, which is greater than the critical angle 42 degree. The critical angle is always be for glass air interfaces will be 42 degree. We have to remember some time it. So you can easily concluded that if the angle of incidence here, as the angle of incidence is greater than the critical angle, so total internal reflection happening. The reflected beam inside the prism strike the surface BC, okay, at an angle of incidence again 45 degrees. So again it suffers, the ray of light suffered the total internal reflection. So the beam of light inside the prism now falls normally on the surface AC and therefore passes undeviated out of the prism and form the image P dash Q dash. So here the object is PQ and image of the object is P dash Q dash of this object, and the beam thus get deviated by 90 degree at each reflection, and the total deviation due to two reflection, if we add this, it will be 180 degrees. So that's why the heading is like that, to deviate a ray of light through a 180 degree. Okay, I think it is understood to all of you. This action of the prism is used for binocular camera to invert the image without loss of intensity. Okay, total internal reflection means the light of ray totally reflected. Okay, totally reflected. That's why here the wastage or the dissipation of intensity of light is not occur. So without of loss of intensity we can get the image of any object. Okay, acha. Go to the next. Here, to erect the inverted image without producing deviation in its path. How is it possible? Here you can see that the beam of light is coming from the object PQ and incident parallel to the face, which is AC. Okay. Here AC is also the hypotenuse of the prism, and after that strike the surface AB, this surface. It suffered refraction from air to glass and strike the face AC of the prism, traveling from glass to air at an angle incidence again 42 degree, greater 45 degree is the angle of incidence here and critical angle is 42 degrees. So it suffers total internal reflection, and the beam inside the prism now strike the surface BC, this surface, and after that the beam inside the prism, after striking the surface BC at angle of incidence which is less than the critical angle, hence it suffers refraction from glass to air. Okay, so here as the light coming from glass and going into the air, that's why it bends away from the normal and the beam emerges parallel to the surface, okay, which is AC, parallel to this surface. As a result, reflection on emergence, the rays are inverted and for the inverted object PQ. So here the erect image that we can get P dash Q dash of the object PQ, which obviously be inverted. Okay, and our prism when used in this manner is called erecting prism. So as a slide projector we use this type of prism. Okay, I hope students this is understood by all of you, and that's it for today's video. In our next video I will discuss about the total internal reflection through equilateral prism. So through right angle prism, the reflection through right angle prism is the types are there. These are the types. Okay, and every types you have to remember. So thank you students, please subscribe our channel.